plate tectonics, and mountain building. In this lesson, we will see how moving plates create the world's biggest mountains, why they grow, and what limits their height. First, the big idea. The Earth's lithosphere is broken into rigid plates that move. Where plates meet, most mountains form. At convergent boundaries, plates push together, shorten, thicken, and uplift the crust. That uplift is called orogeny. One major mountain building setting is subduction. An oceanic plate dives beneath a continent. This builds an accretionary orogen. Think of the Andes. Subduction adds magma, crumples the edge, and thickens the crust. Key features of subduction orogens: addition of magma to the crust, an accretionary wedge that scrapes and stacks sediments, and strong earthquakes along the slab. All of these help build a broad, high mountain belt like the Andes. A second major setting is continental collision. Two buoyant continents converge after an ocean closes. The crust shortens, doubles up, and thickens to extreme values. This builds very high, steep mountains and large plateaus like the Himalayas and the Tibetan Plateau. Collisional orogens show intense shortening and very thick crust, often 50 to 80 kilometers thick. The result is extremely high peaks and broad high plateaus next to them. How do mountains grow? Four coupled processes. 1. Crustal shortening by folding and thrust. Faulting thickens the crust. 2. Magmatic addition from subduction adds material. 3. Isostasy makes a thick crust float higher, like an iceberg with a deeper keel. And 4. Gravity and erosion reduce topography, spreading and wearing mountains down. A quick isostasy picture. 2 columns of crust and mantle. The thicker column has a deeper root, and it rides higher at the surface. Because the right column is thicker, isostasy lifts it higher. The deep root helps the mountain float. As mountains get high, gravity drives spreading and normal faulting, while erosion removes mass from the top. Both effects reduce relief over time. Not all mountains form at convergent margins. 2 other contexts matter, but usually build lower relief ranges. 1. Rifting and extension, which creates rift shoulders and block fault mountains. 2. Hotspot volcanism, that builds volcanic islands like Hawaii. Plate tectonics unifies mountain building in a larger cycle. Oceans open and close. During closure, plates converge and collide, building orogens. Later, erosion and extension lower and stabilize them. This is the Wilson cycle. To summarize, convergent plate boundaries are the main engine for mountain building. Subduction margins create accretionary orogens with arcs and broad high belts, like the Andes. Continental collisions create the highest, steepest ranges and big plateaus, like the Himalayas. Isostasy lifts thickened crust, while gravity and erosion limit peak heights over time. Together, these ideas explain where mountains form, how fast they grow, and why they eventually wear down. Before we finish, here is a side-by-side look. On the left, a subduction orogen. On the right, a collisional orogen. Different geodynamics, same outcome, crustal thickening and uplift. Thanks for learning with us. In the next lesson, we will look more closely at the structures and faults that record these mountain building processes in the field.